Welcome to my first video in my new playlist on generative AI interview questions. In this series, we will cover the different topics step by step to help you prepare with the confidence. Today's topic is all about the foundations of the generative AI and the basic you need to understand before diving deeper. So if you find this video helpful, don't forget to hit the like button, subscribe to the channel and turn on the notification bell so you never miss future video in this series. I would also love to hear your thoughts. Drop a comment below and let me know what topics you would like to cover next. So, alright, let's get started with the foundation of generative AI. So, our first question is, what is generative AI? So, generative AI is a type of artificial intelligence that's designed to create the new things like writing the text, generating the images, composing the music, or even writing the codes. It's different from the predictive AI, which mainly try to guess or classify the basics on the existing data. Generative AI learns from used data set and then uses that knowledge to produce the fresh and the original content. It relies on the advanced model like Gen, VAE, and the transformers. These are deep learning techniques that help the AI understand patterns and generate the realistic outputs. The key point is that it does not just copy what it's seen before. It can actually create the something new. That's why it's so useful for creating the work, simulations, and automating the tasks that requires originality. Next question is, how does generative AI differ from traditional AI? So traditional AI is usually built for very specific tasks like classifying data, predicting outcomes, or spotting the patterns. For example, it can detect whether an email is spam or not. Generative AI, on the other hand, is more creative. It can actually produce the new content that looks like it was made by humans, such as writing an email in a particular style. The key difference is recognition versus the creativity. Traditional AI recognizes and predicts, while generative AI creates. Generative models learn the overall pattern and distributions in the data and then generate the new examples based on that knowledge. This makes them more flexible and powerful, but also harder to control because they can produce the unexpected results. What are the main types of generative AI models? So generative AI has a few main types of model, each with its own specificity. GANs are generative adversarial networks that work like a competition between two parts. One creates a new data, that is the generator, and the other checks if it looks real, the discriminator. This makes GANs really good at producing the realistic image. VAEs are variational autoencoders. It compresses data into a smaller and then rebuild it, which allow them to create variations of the original data. They are useful when you want structured output or control change. Third one is the transformer. It is like a GPT or BERT that use attention mechanism to focus on important part of the text. They are excellent for language tasks such as writing, summarizing, or answering the questions. So each type has its own strength. Jan shine in image realism, whereas VA is in structured variations and transformers in next generations. So together they form the foundation of modern AI system. Next question is, explain the transformer architecture. Transformers changed the game in the AI because they introduced something called self-attention. That means the model can look at every word in a sentence and decide which ones are most important in relation to each other. Unlike the other models like RNNs, which process words one by one, transformers handle all the words at the same time. This parallel processing makes them much faster and able to work with huge datasets. Their structure includes encoder-decoder layers, multi-head attention, and feed-forward networks. The attention mechanism is especially powerful because it helps the model to understand long-range relationship in text. For example, connecting the first word in a paragraph to something much later. This design is the foundation of large language models like GPT and BERT, which can generate the text that is coherent, context aware, and feels natural. What is large language model? LLM. So LLM or large language model is a type of AI that is built using transformer architecture. It is trained on huge amount of text data so it can predict the next word in a sentence. The ability makes it useful for tasks like summarizing the information, translating language, or carrying on a conversation. Examples include GPT-4, Cloud, and LLMA. These models use billions of parameters, basically adjustable settings, to understand the nuisance of language. Their big strength is that they can generalize across many different topics, but they also have weaknesses, like sometimes producing incorrect information or showing bias. Despite those challenges, LLM are the foundation of most modern generative AI applications today. How do GNS work? So GNS or generative adversarial network work like a game between two players. One player called a generator that tries to create fake data that looks real. The other player called a discriminator checks whether the data is real or fake. The generator keeps improving to fool the discriminator, while the discriminator gets better for spotting the fakes. This back and forth continues until the generator produces output that are almost related to the real data. Giants are typically popular for creating the realistic image, deep fakes, and digital art. The main challenge is that training them can be unstable and sometimes the generator gets stuck or on producing only a few types of output, that is called mode collapse. What is prompt engineering? So prompt engineering is basically about writing the right instructions so that generative AI models give useful answers. Large language models or LLM can respond very differently depending on how you phrase the question. So the goal is to design the prompts that make the output accurate and relevant. Some techniques include giving clear context, showing examples, or adding constraints. For example, instead of just saying summarize this, you could say summarize this in three bullet points, which guides the model to produce a structured response. This skill is important because it helps control how the model behaves and reduce the problems like hallucination. Whereas the AI makes up information. That's why prompt engineering is becoming a highly valued skill in the industry that use the AI. What are embedding in AI? Embedding are a way of turning data like words or sentences into numbers that capture their meaning. Think of it as placing words in a big multi-dimensional space where similar meanings are positioned close together. For example, the words king and queen would end up near each other because they share a similar context. This numerical representation makes it possible for AI system to do things like find similar content, group related items, or make recommendations. In large language model, embedding are critical because they allow the model to compare context efficiently and understand relationship between the words. That's why embedding are the backbone of the task like semantic search and the contextual understanding. What is fine tuning in the generative AI? So fine tuning is a way to take a pre-trained AI model and adopt it for a specific job. In this case, instead of building the model from scratch, we retain it using specialized data. For example, medical records or the legal documents. So it becomes more accurate and relevant for that domain. There are two approaches: full fine tuning, where all the model parameters are updated, and partial fine tuning, where only certain layers are adjusted. This makes the process efficient while still customizing the model for enterprise needs. The challenge is that the training data must be carefully chosen because if the dataset has bias, fine tuning can amplify it. What is RLHF? Reinforcement learning with human feedback. So RLHF stands for reinforcement learning with human feedback. It is a method that is used to make AI system behave more in line with what people want. The process starts by collecting human level data where people judge which AI responses are better. That feedback is used to train a reward model. Then reinforcement learning is applied so that AI learns to optimize its answers based on those rewards. This makes the output more useful, safe, and aligned with user expectations. RLHF is a commonly used in conversational AI systems like ChatGPT to reduce the problems such as hallucinations when the AI makes things up or toxic responses. The challenge is that it requires a lot of resources and diverse human feedback to work well. What is hallucinations in generative AI? Hallucinations in AI happens when the model gives answers that sound correct but are actually wrong or made up. For example, a language model might invent a reference or state of historical fact incorrectly. This happens because the model is predicting patterns in a text, not checking whether the information is true. It is a big challenge in areas like medicine or law, where accuracy is critical. So, to reduce the hallucinations, we can connect the model to a reliable external data, add human review, and design better prompt. These steps may help make to output more trustworthy. How do you evaluate generative AI output? So how we evaluate AI depends on the type of output. For text, we often use matrices like BLEU or ROUGE, which compare the generated text to reference text, along with human judgment to check quality. For images, measures like FID and IAS are used to see how realistic the images look. For audio, we usually rely on MOS or mean opinion score, which is based on human ratings of sound quality. The key point is that automated matrices are good at checking similarity, but they don't compare the originality or the creativity. That's why human evaluation is still very important. A balanced approach combining automated scores with human feedback ensures the output are much accurate and meaningful. What are ethical concerns with generative AI? So, generative AI is powerful, but it also brings some important challenges. One issue is misinformation. For example, deepfakes can be used to spread false stories. Another is bias, because if the training data is biased, the AI can unintentionally amplify the discriminations. There are also copyright concerns whether the AI generate content that looks too similar to existing work, and privacy risk if sensitive data is used in training. That's why ethical framework and regulations are so important. They help balance innovations with responsibility, making sure AI used safely and fairly. How can be how can bias be mitigated in generative AI? So bias mitigation in AI means reducing unfairness in how models behave. To do this, we need diverse training data sets so that model doesn't learn only from one perspective. We also use techniques like de-biasing algorithms, fairness rules, and human oversight to catch the problems. Being transparent about where the data comes from helps identify issues early. Regular audits and bias detection tools are important to keep track of performance. It's important to note that bias can't be completely removed, but by acknowledging the limitations and continuously improving the safeguards, we can make AI system more ethical and reliable. What is zero shot learning? So zero shot learning means an AI model can do a task even if it hasn't been directly trained on the example of that task. It uses the general knowledge it learned during pre-training to handle new situations. For instance, a language model might be able to translate a language that were not specifically trained on because it understands the meaning of words across different contexts. This makes the model very versatile, but the trade-off is that accuracy can be lower compared to supervised learning, where the model is trained with the clear examples. What is few shot learning? Few shot learning means teaching the AI model to do a new task using only a handful of the examples. So instead of retraining the whole model from scratch, we give it a few samples like three examples of positive and the negative sentiment. And it uses its existing knowledge to generalize and perform the task. This approach is more efficient, saves time and resources, and still gives good accuracy. It is especially useful in areas where we don't have a lot of level data, such as specialized domains like medicine or the law. What is transfer learning in the generative AI? So, transfer learning is about reusing knowledge an AI model has already learned in one area to help in another. For example, a model trained on general text can be fine tuned with medical data so it works well for healthcare applications. This saves a lot of time and cost compared to training a new model from scratch. It's one of the foundation of modern AI because it allows rapid adoption to a new domains. The idea is that many tasks share the common structure so the model can transfer what it knows. The challenge is making sure that the new dataset is carefully chosen, otherwise, its mismatches can cause the errors. What is the difference between supervised and unsupervised learning? So, supervised learning means the model is trained with labeled data, that basically examples where the correct answer is already known. That's why it's used for tasks like classification, where we assign the categories, or regression, where we can predict the numbers. Unsupervised learning, on the other hand, works with the data that has no labels. The model looks for hidden patterns or the groups, which is why it's used for the clustering or reducing the dimensions. Generative AI often mixes both approach. For example, VAs use unsupervised coding to learn the data pattern but rely on supervised evaluation to check the results. The key difference is whether the training process is guided by ground trust level or not. What is multimodal generative AI? So multimodals are AI systems that can work with more than one type of data like text, image or the audio. For example, a text to image model such as DAL it can turn written descriptions into the pictures, while an image to text system can generate captions for photos. These models combine the vision, language, and sometimes sound to produce richer and more natural outputs. Similar to how humans communicate using both words and the visuals. The main challenge is making sure the model aligns the information across these different modalities correctly. But when it works well, multimodal AI greatly expands the creative possibility and makes interactions with AI feel more natural. What is diffusion in generative AI? Diffusion models create images by starting with random noise and then gradually cleaning up it step by step until a clear picture emerges. Think of it like polishing a blurry photo until it becomes sharp. The process allows them to generate very high quality photorealistic outputs. Well known examples include the stable diffusion and denoising diffusion probabilistic model. The downside is that they require a lot of com- computing power, but they are completely transformed the field of image generation. What is the role of attention in the transformers? So attention mechanism helps AI model to focus on most important parts of the input. Instead of treating every word equally, the model assigns weight to different tokens so it can capture the context and relationship more effectively. This is especially useful for understanding the long range dependency in the text, like connecting the beginning of a sentence to something much later. Multi-head attention takes this further by allowing the model to look at the input from multi-line perspective at the same time. The innovation at the same time, This innovation is what makes transformers so powerful and scalable, and it's the reason they work so well for the tasks like translation, summarization, and the text generation. What is tokenization in LLM? So, tokenization is the process of breaking text into the smaller pieces, like words, subwords, or even characters, so that an AI model can understand the process. For example, the word playing might be split into play and ing. This makes the model more efficient and reduce the complexity. It's especially important because it allows the models to handle different language and large vocabulary. Tokenization is the one of the first and the most critical steps in natural language processing, since without it the model wouldn't know how to represent text in a way it can work with. Next question is, what is the difference between the open source and proprietary LLMs? So open source are the AI systems that are transparent and community driven. They can be customized and experimented with, which makes them flexible and great for innovations. For example, include LLMA or Falcon. The trade-off is that they may not be as polished or user-friendly. Proprietary models like GPT-4 or Cloud are closed and commercial. They are optimized, reliable, and usually come with professional support, but they don't allow much customization. So the choice between the open source and proprietary depends on what an organization needs, whether it values flexibility and control or reliability and ready-made support. What is turning test in generative AI? So the turning test is a way to check if the AI can respond so naturally that a human judge can't tell whether they are talking to a machine or a person. If the judge can't reliably spot the difference, the AI is said to pass the test. It's an important idea in the AI history, but it has limits. The test only measures how human like the conversation feels. It doesn't check if the answers are factually correct, creative, or ethically aligned. That's why modern benchmarks go beyond the Turing test to evaluate a wider range of AI capabilities. What is the role of GPU in generative AI? So GPU are the special hardware that speed up the heavy calculation that is needed for the AI. They are designed to handle the matrix operations very efficiently. That are the core to deep learning. Without GPU, training large language models would take an unrealistic amount of time. They also make real-time applications like chatbots possibly by quick processing responses. In short, GPU are essential for modern AI because they make both training and inference practical and scalable. What is overfitting in the generative AI? So overfitting happens when an AI model memorizes the training data instead of learning general patterns. As a result, it performs well on the data it has seen but struggles with new unseen data. In generative model, this can show up as repetitive or uncreative output. So to prevent overfitting, we use the techniques like regularizations, dropouts, and data augmentation. The key is to balance the complexity of the model with the diversity of the dataset. So the models learn to generalize rather than just memorize. What is model distillation? So model distillation is a technique where we take a large complex AI model and compress it into a smaller one while keeping most of its performance. The idea is that a big teacher model trains a smaller student model to mimic its output. This makes a smaller model more efficient and less resource hungry. Distilled models are especially useful when deploying AI on devices with limited power, like mobile phones or the edge devices. They strike a balance between the accuracy and practicality, which helps to make the AI more accessible and easier to use in the real world applications. What is the difference between the pre-training and fine-tuning? So pre-training is when an AI model learns general pattern from very large data set like language or images. So it builds the broad knowledge. Fine tuning comes whether after that it adopts the model to a specific task or domain, such as medical text or the legal documents. Pre-training gives the foundation while fine-tuning makes the model relevant and accurate for specialized use. So together this two-step process makes AI model both versatile and efficient, and it's a core approach in the modern AI development. Next question is, what are real world applications of the generative AI? So generative AI is a technology that can create the new content like text, image, music or even designs. It is widely used across the industry. For example, in content creation, it powers tools for writing art and music. For healthcare, it helps with drug discovery and analyzing the medical images. In finance, it is used for fraud detection, automated reporting. In education, it supports personalized tutoring or the curriculum design. Because it can adapt to so many areas, generative AI is considered transformative across the industries. Next question is, what is synthetic data? So synthetic data is a data that we artificially generate instead of collecting from the real world. It is often used to make training dataset bigger and more balanced. For example, gens are create synthetic model images to help train the models when the real medical data is limited or sensitive. This approach helps reduce bias, protect privacy, and expand the dataset. It is especially useful in situations where real data is scarce or hard to share. But the key challenge is quality control. We need to make sure synthetic data is accurate and doesn't introduce any error into the model. So thanks friend for watching this video. I hope you found this video so much helpful and you learned something new today. So if you enjoyed it, don't forget to hit and the like button, subscribe the channel and turn on the notification bell so you never miss the new future videos. I would love to hear your thoughts, so you don't miss to drop a comment and let me know what topic should I cover next. So until then, keep exploring, keep learning, and I will see you in the next one. So stay curious, stay inspired, and stay AI powered.